Now we're going to talk about explicit formulas. So we're going to have to list a sequence from its explicit formula, and then we're going to find an explicit formula from its given sequence. So let's look at this sequence, 1, 4, 7, 10, 13. Notice each time we're adding 3. The recursive formula would be a sub n minus 1 plus 3. Remember, the definition of recursive formula is that you find a sub n using previous terms. When we do an explicit formula, instead of using previous terms, we're just going to use the position. So in this case, to get each number, we have to multiply by 3 and then 3 by the position and then subtract 2. So for example, number 1 is in position 1, which means n is 1. So 3 times 1 is 3, minus 2 is 1. The 4 is in position 2, so n is 2. 3 times 2 is 6, and 6 minus 2 is 4. 7 was in position 3, so n is 3. So 3 times 3 is 9, minus 2 gives us the 7. So the explicit formula for the general term tells you how to calculate a sub n from the position without using previous terms. You're just going to use the n. No a sub n something. You're not going to use a sub. You're just going to use n. So let's practice. Let's find the first 5 terms of a sub n, which is equal to n squared plus 1. So this is an explicit formula because we're not using previous terms. So a sub 1, we're going to plug in 1 for n, so 1 squared plus 1 is 2. A sub 2, we're going to plug in 2, so 2 squared is 4 plus 1 is 5. Our third term would be a sub 3, so n would be 3. 3 squared is 9 plus 1 is 10. A sub 4, our n is 4, so 4 squared is 16 plus 1, which is 17. Our a sub 5, our n is 5, so 5 squared plus 25 plus 1 is 26. Not every sequence is going to have an explicit formula. Sometimes you're not going to be able to give a formula without using previous terms. However, if you do have an explicit formula, you are going to have a recursive formula, just not vice versa. Let's try to find the explicit formula and give the 10th number, or the 10th a sub 10. So we have 1 plus x for our first term, for our a sub 1. Our a sub 2 is 4 plus x. Our a sub 3 is 9 plus x. And our a sub 4 is 16 plus x. So the way you can think about it is that this is n equals 1. This is n equals 2. This is n equals 4. N equals 3, and this is n equals 4. Notice that each time you're taking your n and you're squaring it to get these numbers. So our formula would be n squared and then just tack on a plus x. And that's our explicit formula. So if we want to find a sub 10, we would do 10 squared plus x, which is 100 plus x. Let's try one that's a little bit harder. We have 6, 10, 14, 18, and 22. So when n is 1, we have 6. When n is 2, we have 10. When n is 3, we have 14. When n is 4, we have 18. And when n is 5, we have 22. Now, to get from 6 to 10, you add 4. And then to get 14, it's 6 plus 8. And to get 18, it's 6 plus 12. And then 22 is 6 plus 16. However, that 4, that 8, that 12, and that 16 can be rewritten as 1 times 4, 2 times 4, 3 times 4, and 4 times 4. Which means that we take our 6 and we add 4, because remember each one had a 4 in it, times n minus 1, because this is our second position and we had a 1. This was our third position, we had a 2. This was our fourth position, we had a 3. This was our fifth position, we had a 4. That's where the n minus 1 came from. So go ahead and distribute the 4, and we get the formula 6 plus 4n minus 4. Then combine like terms, and we get 4n plus 2. So for every special recursive sequence that we have, the arithmetic, the geometric, the factorial, the harmonic, and the Fibonacci, there's also going to be an explicit formula just for them. So here's the chart for that. This n with an explanation point is called n factorial, so an n factorial is you multiply that number followed by each number after that. So for example, 5 exclamation mark or 5 factorial would be 5 times 4 times 3 times 2 times 1.